So this week, although the dates are wrong, the picture's right. So there's a couple of things to read. There's an activity on weather and climate, which I'm going to talk about. And so there are some videos. And so ideally, you'll watch all of the videos, and then you will turn in some sort of proof. So in the past, students have taken notes. Some people have just written like a summary and talked about their favorite parts. You want to make sure you talk about, you know, a good portion of it. I mean, you don't have to, I mean, ideally you'll give me the impression, which is the hardest part, of that you actually, you know, watched the video. So the first one, these are videos we used to watch in class that that I want you to still have access to. They're put on by the BBC, and I think it was BBC, maybe Discovery. Anyways, and what it is if ideally I could create all of these things, I would. It's what I like to think of as a combination between Misfits and Mythbusters, all about weather and its devastating forces. So the premise behind it is there are three factors that are involved in our weather: wind, temperature, and precipitation or rain or water. So, and those three things combine to make all of the weather phenomenon we experience. So whether it be a tornado or a hurricane or these huge heat influxes, you know, so you would ideally watch the videos, but there were some parts that were left off of the video that I found online, meaning the video I had different clips in it. So the first one is kind of like an overview of the three factors of wind, water, and temperature. The next one is just a cool video. I'm gonna see if I can, oh, it doesn't link. All right, I wanted to show you the second video because it's kind of coolness. So you get an idea of what this guy's like. Wrong thing. Okay, so sharing is caring. New sharing, no. New sharing, no. Oh, here it is. Here we go. Okay, and we go play.
We talk about heavy rain, but water is heavy, very heavy. To give us an idea of just how heavy, we are about to see what would happen if all of Borrowdale's 4 metres of water fell in one go.
Now, obviously, we can't get a digger the size of the Lake District. So we're just going to recreate what it's like when 4 metres of water hits one small area.
So we have 4 cubic metres of water in the bucket, which amounts to 4 tonnes at height. Then beneath it, you'll see we've found a car for scientific purposes.
Let's see just how much damage that amount of water can do. Looks like rain. Yeah, pretty brutal. But I shouldn't be surprised, because the water actually weighed 4 times more than the car underneath it. Every minute of every day, 900 million tons of rain land on our planet. That's about the same amount of water as in all 16 lakes of the Lake District.
Oh, they're going to notice. But it does prove the point. Water is really heavy. That is just the annual rainfall for Borrowdale, where I've been going on holiday all of my life. Explains something about it. It's amazing, isn't it?
All right, so that's just one of the videos. I just wanted to give you a flavor for what Richard Hammond is like, and kind of sort of what he does. So he sets up these little experiments so that you can see it on a smaller scale, and then talk about weather in a interesting and fascinating, fascinating, my opinion, way. So, all right, so back to our little. The weird thing about the way it's set up is one of them says, so I showed you the clip, which is the second video. So you're going to watch the whole first video, and then you're going to watch the third clip. Starts a little bit in because it's got stuff we've already seen, and you're only going to watch it till about 30 minutes in. So you're only going to watch about 20, I think like 20 minutes, if I remember correctly. So it's a good chunk of time. So you don't have to write a doctoral thesis or dissertation on it, but just give me the impression, talk about some of the cool things you saw, and if you're really into it, I actually put the links to the three full videos if you want to watch them, because the first one's just like clips of each of the three, and then I added some other stuff in. So anyways, I've talked way too much about these videos, but that's because I like them and I miss them, because I used to watch them 3 times a year, and now I only watch them. I watch clips of them, so I should go back and watch them, because no, I have other things to watch. I'm sorry. All right, so this week we're talking about weather and climate, and the funny about weather and climate is that climate is what you expect. Like in California, our climate is technically Mediterranean. So we expect it to be fair and mild to moderate. Like we don't expect these, we don't expect to get super duper hot or super duper cold and things like that. But weather is what you get. So the more scientific way of looking at it is climate is the aggregate total of temperature and precipitation values over a long period of time based on a monthly average. And weather is, what is it like outside right now? Is it windy? What is the air pressure like? What is the temperature? Is it, snowing? Is it raining? Is it hailing? Is there a thunderstorm? What's the dew point temperature and stuff like that. So we're going to spend some time talking about weather. This is a typical weather forecast, not from today. I should have actually replaced this because the weather map today is kind of cray-cray. They're expecting some interesting storm situations in the southern part of the United States. So that would have been kind of cool. I could have updated, but I was too busy watching documentaries about refugees. I don't know how I got on it. It just went down a refugee wormhole this morning. So when I should have been, updating my slides. So this is a weather map. It shows you where the high and low pressures are located. These are showing a couple of tropical storms and a hurricane. These are cold fronts. The blue ones with the teeth are cold fronts. These are warm fronts. We have isobars and isolines and lots of cool stuff. And so this is what a weather map looks like. So again, weather is it raining? Is it snowing? Is there a hurricane blowing? Is the grizzly weeper rowing? It's certainly not showing any signs that it's slowing. That's from Charlie and the Chocolate Factory. So this is a weather station model. So this tells us everything we want to know about the weather aggregated on a 3-hour period. So this is what the weather's like now, and it gets updated every 3 hours. So this tells us the temperature. So it's 74 degrees in this location. The dew point temperature is 72. So that tells us that it's relatively humid. You can see about, 10. So that's about 1 mile. You can see about a mile. So it's clear-ish. It's got wind, 15-mile-an-hour winds. The pressure is, 1,000 something. It's changed. It's gone down about 3 points in the last 3 hours. So it tells us, and it's partly cloudy, meaning it's like 50% clouds right now, versus this one that says it's fully cloudy and this one that says it's clear. And so these symbols represent the conditions at a particular location. So there are a variety, and I'm not sure if I talked about them. I feel like I did. The factors that influence temperature, and have the mnemonic device lower in CV. Yes, no, maybe. Have I talked about them yet?
I don't think so.
Okay, cool. Fabulous. Thank you. The factors that influence temperature, which is an impact on both weather and climate, are latitude, so how high you are from the equator. So if you're near the equator, it's going to be hot or warm. And if as you get further north, it's cooling off. You're not going to see 90-degree temperatures in the North Pole. It's just not going to happen. No matter how much global warming occurs, it's physically impossible unless the sun starts doing something different than it's doing now. It's just, or we get knocked off our axis, I suppose, that would do it. So that's latitude. The second one's ocean currents. What kind of ocean current do you have going by you? So we have a cold current off our coast versus the warm currents that are off the east coast. W stands for winds. So that has to do with, where are the winds coming from? How often do they occur? E stands for elevation. The higher you are in elevation, the cooler your temperatures are for the most part. Sorry, Alexa was beeping at me and I was like, why is she beeping at me? She's very distracting. R stands for relief. In Southern California, we've got this great phenomenon on the south side of the mountains where Glendora and Citrus and Pomona and Los Angeles are located, have a different climate and weather situation than, say, the other side of the mountains where like Palmdale and Victorville and places like that are located. And that has to do with which side of the mountain you're on and which way the prevailing winds are coming from. N stands for nearness to water or proximity to water. Why are they in my practice Zoom room? Hopefully they find me. So if you're closer to the water, you're going to have different things depending on, what water we're talking about. So in our particular case, in Southern California, your proximity to water is going to give you a milder temperature. So for example, in Santa Monica, in the summer, it's like 70, 80 degrees. If you just go inland to downtown Los Angeles, it's 10 degrees warmer. And if you go further inland to the Inland Empire, it's 10 degrees warmer because of that, the ocean's influence on, and the fact that the further away you get from that. And other places like Chicago, nearness to water would be the Great Lakes. And so they get what we affectionately call, we as in us weather people, lake effect snow. Also impacts New York City. So cold, frigid air comes over the Great Lakes and picks up lots of moisture. And then because it's cold, it can't hold on to that moisture. So it buries places like Chicago and New York City in feet of snow. C stands for clouds and V stands for vegetation. So clouds are, well, those big puffy things. Well, they form they do two different things. So incoming solar radiation is reflected off the clouds. If you remember from the energy budget week, where you learned about the energy budget, incoming solar radiation, some of it gets reflected off the top of the clouds. Well, what then happens is it penetrates, it hits the ground, it reflects off of different surfaces and lots of other stuff, and then goes back up. If it hits the bottom of the clouds, some of that energy, just like on the top of the cloud, got bounced off and sent back out to space. In this particular case, it's going to get bounced off and sent right back down to us. So it creates this warming effect. And so where you see a lot of that is, you know, the difference between the deserts and, say, the beach, right? So for example, you know, you can see temperature differences within a day of like 20, 30, sometimes 40 degrees in a desert. So it's really hot during the day, but then it cools off as soon as the sun goes down. That's because there's no clouds to keep that radiating heat, that latent heat that's being re-released to the atmosphere in. It just re-escapes out to the upper troposphere and into the stratosphere and beyond, right? But if there are clouds, then some of that energy is going to be reflected back in and keep us kind of like warm. So in the past, scientists used to describe it like a blanket, but then we got knocked on the head because it's not really a blanket, because it doesn't do what blankets do. And I'm like, who cares? If people think about a blanket, it keeps you warm because it keeps the heat in, you know, but it's not really keeping the heat in. What a blanket's really doing is keeping the heat out. And I'm like, well, that's kind of what clouds do too. They keep some of the heat out and some of the heat in. But anyways, and the last one is vegetation, which relates to a concept known as albedo. Not libido, but albedo. Albedo is the reflectivity of a surface. So different surfaces have different amounts of reflection. So for example, snow has high reflection, so you can get really sunburnt when you're on the snow because the radiation hits that reflective surface and reflects right back up at you, versus a dark surface such as blacktop or asphalt. It's going to absorb a lot of that incoming radiation. Well, vegetation is actually a really good absorber of energy, and it kind of stores it for a little bit and then re-releases it later on when it's not, when the incoming radiation stops, it starts releasing it. So white surfaces reflect it, black surfaces absorb it, and then of course re-radiate it out as heat energy later on. But vegetation is a little different. It absorbs it and then kind of transforms it a little bit. So when it radiated out, it doesn't store as heat energy. It's storing instead as what we call latent heat, which is, I guess it's the same. But moral of the story is, if I told you to go stand outside in the heat of the summer and I gave you 3 places to stand, you could stand on the concrete, you can stand on asphalt, or you can stand in the grass. Choose the grass, okay? A lot of that energy is being absorbed by the vegetation to be used for photosynthesis, and so it's like converted into other things, and so it doesn't give off as much heat. So lots of fun stories that I'm sure I can talk about later on about that. So again, this presentation will be given to you, so if you didn't get everything I said, then you can look at my notes down at the bottom, and a lot of what I said is most likely in there. I would tell you, except for I lost the screen that tells me what I'm supposed to be saying right now. So this is my pause so I can find that screen. Just kidding. So John Steinbeck, writer of many a great novel, wrote, "I live in a good climate and it bores the hell out of me. I like weather rather than climate." I'm the same way. I started teaching at Victor Valley College. It was the first college I taught at, and a couple of semesters ago. Actually, I guess it was last year because I did it during the pandemic. It was all fine and dandy until this pandemic came along, and I had to try and teach weather and climate. So they asked me to teach a weather and climate class in Victorville, and I said, oh my gosh, first of all, why are we teaching, weather and climate in California? Because if you look at our weather, it's like sunny and warm, cooler and, cool and breezy, but, it's partly cloudy, fair weather. It's like boring. And when you go to the desert, it's even more boring. It's like, oh, today it's going to be windy, tomorrow it's not, So there's not a lot of stuff going on. So because I live in a good climate, see, California's got a great climate, but we don't get much weather. So I always jokingly said, oh, look, we're having some weather. I get really excited when it rains. I have a friend of mine who I call and I'm like, hey, it's raining. Because good thing it's not the only time I call them, because otherwise we'd never talk. That was a little kind of weather joke. Yeah. We've weathered many a storm together. Pun. All right. So temperature and precipitation is all that makes up climate. So that's it. Just temperature. And again, it's averaged over a long period of time. And then again, it's averaged over the month. And so, you get a lot of, you can have variable, like widely variable weather, but your climate can be relatively boring. And that has to do with this aggregation of things. And so, again, we've got the same things that are going to impact our climate that impacted our weather as far as temperature, because again, temperature is temperature. So again, lower in CV, that's the little mnemonic device that I came up with. So latitude, ocean currents, wind, elevation, relief, nearness to water, clouds, and vegetation. In the book, I think it calls it proximity to water. Instead of saying relief, it says aspect, which is just another name for relief. Instead of elevation, it says altitude, but that doesn't fit my lower in CV thing. So, but they all mean the same stuff. So, all right. So the purpose of this here is the purpose of classifying climates is to understand distribution and to allow for comparison. So if without it, we would just look at the world and go, oh yeah, it's hot there and it's cold here. But if we can classify these into groups like geographers like to do, we like to create regions of stuff, then we have something that we can understand, we can look at where it's at, and then we can also compare different places. So there are 6, I know there's only 5 shown here. I'll tell you what the 6th one is going on in just a second. But there are technically 6 major climate classifications in the world. And they are A, B, C, D, E, and H. And I'll talk a little bit about each of those here coming up. But before we do that, let's look at what the Greeks used to think about the weather. Now you need to understand something about Greece. It's located near the Tropic of Cancer. And if I haven't said it once, I've probably said it 100 times. He who makes the maps makes the rules. And so the Greeks were coming up with naming of the climates. And so they said that the area that they lived in was temperate. It's the ideal place to live, right? And anything else is just horrible. It's either too hot, which they call torrid, which always reminds me of horrid. And then there's the frigid zone where it's too cold, right? So they only had 3 climate classifications. The area that they were in, which was ideal. Then there's the frigid zone where it was too cold. And then there was the hot zone, which they called torrid. We use a little bit more along this 5 zone thing. So the next way to break down climates after the Greeks was into this 5 climate system. So We had 1, which was warm and wet. We had 2, which was dry. We've got 3, which is what they called like a warm temperate or subtropical warm temperate-ish kind of thing. Then we had mid-latitude cool, and then we had cold. And this is a little more kind of where we were. So we went from, the Greeks to more of the Eastern hemispheric system, again, Eurocentric, looking at the climate system. So ideally, if the Earth didn't spin, this is what our systems would look like. We would have our A climates in between the tropics, essentially. So between 0 and 23 degrees north and south of the equator. Then we'd have our B climates, which are considered arid, which would go between 23 and 30 degrees north and south of the equator. Then we had our C climates, and then we have our D climates, and then we have our E climates. And the only letter that's missing from this is H, and that's because it can occur anywhere because it stands for highland, right? So that's an elevated place. And as I said before, your temperature and your precipitation, believe it or not, are going to be impacted by your elevation. So the higher you are up, the less likely you are to, the colder it's going to be. And it's also, probably, well, depending on where you're at, your precipitation may be impacted because cold air has a hard time holding on to moisture. So sometimes by the time it gets to you, there's no moisture left. So although it's cold enough for there to be, rain or snow or stuff like that, it may not be that way. So in fact, one of the driest deserts in the world is actually in a very elevated place. And that's because there's just not a lot of moisture. So once they changed the definition of a desert to the amount of, essentially the amount of outgoing evaporation exceeds the amount of incoming precipitation, then that's considered an arid climate. So you can have highlands, and your highlands don't necessarily mean that there's no rain. It could be a highland arid climate also. So we'll look at some of those today before we go.
Can I ask a question?
You can.
You had said that, I guess, the higher elevation, the less moisture.
Yep.
So then, let's take Mount Everest, for example. I mean, that's like, the highest point.
Yep.
Would you not consider the snow to be moisture?
Okay, so have you ever listened to them talk about the Sierra snowpack?
No.
No? Okay, so we in California pay particular attention to how much snow falls in the Sierras,
Okay.
right? But snow does not, although you would assume that snow is wet, and it is, I'm not saying it isn't, but it's not as wet as rain, believe it or not. So there's a lot of, and one of the things you'll see in the video for this week is they talk about ice and how it's like snow and how it's constantly changing.
Mm-hmm.
And the ice crystals are forming and reforming and stuff like that. And so if we were to take that and compress all of the air out, there actually isn't that much there. So although there is snow and it's probably glaciated, it's covered in glaciers and things like that, it's not super, the air isn't super moist. It's not humid. It's certainly not like the tropics as far as moisture is concerned. And that has to do with the fact that it can't hold on to a lot of moisture. So, for example, like 0 degree air can only hold on to, like, we'll just say 1 grain of moisture. And if it was like 80 degrees Fahrenheit, it can hold like 30 grains of moisture.
Okay.
The air itself. So although there's snow, that does not mean it's not arid. So it's often confused, but you have to think of snow as like fluffy water. It's like an ice cube. Remember that ice water is an interesting thing. When it freezes, it expands, and that expansion is partly due, in fact, to the fact that it's got a lot of air pockets in there. So when the molecules start slowing down, they get further apart, but they're taking up more space. Volumetrically, it's larger, but moisture content, very small. So it's like going skiing in the Sierras, which we affectionately call Sierra cement. It's very wet snow in the Sierras versus skiing in the Rockies. They have a very dry snow in the Rockies. It's fluffy, it's light. So if you ever watch skiing or snowboarding videos, not the like X Games where everything is like all, like perfectly groomed, but like where they go through it's just a much lighter snow. And so although it's snow, it's not necessarily super wet snow.
Okay.
If that makes sense.
It does. It does. All right. It was just.
I know it seems counterintuitive. It really does. I agree. It does seem counterintuitive. You're like, it's snow, it's wet, it's snowed, right? But there's a lot of air, and then the air itself can't hold on to a lot of moisture in and of itself. So, if you think about the moisture coming out, of the cloud, a cold cloud can hold, like a Dixie cup worth of water, and warm air can hold like, a 32-ounce bottle of water.
Okay.
So even though it's cold and there's snow, this has got a lot more moisture in it and so it's not just what's on the ground, it's what's in the air. And so the capacity is a lot smaller at colder temperatures.
Okay. Thank you. And sorry to interrupt.
No, please. It gave me a chance to drink some water. I appreciate it. Thank you. Interrupt anytime you want.
Thank you.
So this is looking at that same model I had with my A's and my B's and my C's, and looking at a more specific kind of system, which is based on this guy named Köppen, who was a German guy who came up with the system. So again, he was in Germany. So the first place they created the zones for was here. So they knew that they needed to break it up into, 2 zones before they get to us. But if you think about it as how they named stuff, they named it based on where they lived, which was mostly in the C and D climates. So C is is temperate. Remember, temperate means, ooh, it's nice to live in. And D is known as continental. So that's a little further north, but still an okay place to live as far as they were concerned. So the first letter, the capitalized letter, is going to deal is the major group that it's in. So A, B, C, D, E, and then H. You see it's over here by itself. It's just called an H climate because it can be anywhere. So they just call it H. It's like, oh, that's elevated, and that's why it's so weird. And then the second letter deals with the precipitation that is involved with that particular location. And so I've come up with some fancy ways to remember these things. So the second letter, so the one after the major letter, is the rain, right? How much precipitation. So if there's a W, that it tells you when it's dry. So that means it's a dry winter. And if it's a S, little lowercase s, then it's going to be what we call a dry summer. So you can tell when it's going to rain. And then M means it has what we call a monsoon season. So it's got a season where they get all of their rain. And then F means it rains all the friggin' time. So Yeah, so you have it down here too. So you can have a humid continental, rains all the freaking time, dry in the winter. Okay. All right. So that's that. And then the next letter. Oh, so that clears up the first one. The next one is the dry climates, or what we call arid, right? And so W is a true desert. So for example, the Sahara is a true desert. It's a BW climate. S stands for a steppe, and it's what we call semi-arid. It's technically what we hear in, say, the Mojave or Arizona. That's the type of climate they have it there most often, is a steppe. It's they get a little more rain, but not a lot of rain, kind of thing. And then H stands for hot, and K stands for cold, because remember, he was German, so cold starts with a K in German. So yeah. If we look at the C and the D climates, are temperate, or what they call mid-latitude, and our continental or severe mid-latitude. That third letter, we already talked about the second letter, little lowercase letter, deals with when it is raining or not raining. So dry summer, rains all the freaking time, dry winter, freaking time, all the freaking time, you get the point there. This third letter stands for, they just went, they weren't very creative. So I can't say anything really funny about this. They literally just said A is hot, B is warm, C is cool, and D is cold. Like I said, not very imaginative, but you know, he who makes the rules. Yeah, okay. And then there's two polar climates. Those are going to be those E climates way up. There's the tundras, and then there's the ice caps. So it's like cold, and then like, yeah, it's just beyond cold. So, and then there's highland. So these are Köppen's classification system, and if you get into weather and climate, you will spend some time figuring out what all of these mean. And as far as, so if you recall at the beginning, I showed you the little weather symbols, right? This is essentially the symbol of a climate right here. It's what we call a climate graph. It represents, it's a graphic representation of monthly temperature and precipitation. And so this tells us a lot about what's going on. And you can actually take this and figure out that this was a mid-latitude, rains all the time kind of place that is hot, because, and notice hot is a relative term. It's 80 degrees and they say that that's hot. Like, would you consider that hot? Like, no, I wouldn't either. But it is. It's technically considered a hot climate if it's over 80 degrees. So yeah, that's a good portion of our planet is going to be in that particular case. So, but there's other things we could have learned from this. Even if the map wasn't behind it, I could have told you that this was in the northern hemisphere because of when the temperature peaks. This right here shows it rains all the time, so we could figure that out. There's one climate, oh, I forgot to mention this. The reason why there isn't anything about precipitation in this one, which I forgot to mention, there is no like second letter. The second letter for this is a capital letter, which deals with whether or not it's a true desert or it's a steppe. Is because this is the only, it's like if you're looking at the Köppen system and trying to classify stuff, the first question says, does it get less than 15 inches of rain? And if your answer is yes, then you're in an arid climate, you're in a B climate. End of conversation. It's the only one that's based solely on how much precipitation they get. It's not an afterthought. So with the B climates, it's all about how much precipitation is received. And it's the only climate that's like that. Everything else is based off of temperature. So, so I talked about that. So this is a map, and again, you can see a lot more about these in my little slideshow. I want to give us enough time to ask questions at the end. So this is the tropical climate. So again, you can see that those raining all the time ones are right along the equator. So as you would expect, the Amazon rainforest and places like that. These are our arid climates. So we have our true deserts, and then we have what we call our desert steppe. So if you're familiar with United States geography, then you know that this is a good portion of the Central Plains. This is the area just on the other side. This is the Rocky Mountains right here. This is the area on the other side of the Rockies. So that's like, you know, Colorado and places like that, and a portion of the Great Plains. This is the Sahara that covers this swath. And then just below that is a steppe. It's a grassland, is what you should think of as a steppe. It's like a tall grassland. These are going to be our, you know, our temperate climates. So most of the Midwest and the South. Those are, and again, you can kind of see that banding that I talked about at the beginning with the idealized globe, where I split it into A, B, C, D. For the most part, they're kind of falling into that area-ish. So you can see that we, along the coast of, you know, California and all the way up into Washington and Oregon and all the way up into British Columbia and all the way up to Alaska, are living in what is called a Mediterranean climate. What that means is we have a wet winter and a dry summer, just like the Mediterranean does. So, and then we've got those lovely, lovely continental climates. So it's got 4 recognizable seasons. You know, long, cold winter, very short summer, but you know when it's summer, because it's, you know, actually time to maybe put on a pair of shorts because it got above 50 degrees. You're like, ching, time to put on some shorts. And then these are the extreme latitude, so the poles. So these have, you know, no temperature in this is above 50 degrees Fahrenheit, which is still warm enough to melt ice, but not warm enough, if you ask me, to put on a pair of shorts. And it's extremely dry, but it's not classified as arid. But it is dry, like I had said before, mostly because there's low evaporation. So, and then I like to call these cold and frozen. So T is, you know, tundra, and F is an ice cap. So I call it colder and frozen, like, yeah, like, you know, Anna and Elsa. Let it go, let it go. And then this is looking at the variation across the latitudes based on elevation alone. So here you can see these are about the same latitude. So we've got Sacramento in the Central Valley, and then about midway up, we've got a town called Placerville. And then if you go up even further, it's Twin Lakes, and these are the climate graphs for each of those places. So in addition to the temperature going down, you see the precipitation values also. Although they're higher in the colder months, they all kind of go down, and that has to do with, you know, the fact that they're in California, and it is what it is. So I think that's my last slide. Yes. So any questions? Let me take a look at our module this week, see if there's anything else I need to talk about. There's a quiz. Oh, I gotta check that quiz. I'm gonna write that down. Check quiz. Need to make sure I have all the right answers. And that it's pulling from the right group of. I had a problem already today. I was like, why is that pulling from that pool? That's not supposed to pull from that pool. So I need to double check and make sure that I, you know. Your discussion for this week is a little different than in previous weeks. So ideally, you will have at least watched the little video on weather, the first one in your weather and climate thing before you answer the question. It talks about the question is, you know, you have to define what is the difference between weather and climate, and then of the 7 factors that influence temperature, latitude, ocean currents, wind, elevation, relief, nearness to water, clouds, and vegetation, which one do you think is most important? How does it impact the climate? And why is it the most important or the biggest factor? And you can quote stuff from the book, you can quote stuff from the video, you can just talk about your own experience. But you will need to post before you can see other people's replies. And so, yes, you still need to reply to other people, but I want you to not be influenced by what other people say. I want you to, you know, get in there and kind of put yourself out there in the sense that, you know, pick one. An argument can be made about any of these. So this would kind of be like, if you want to say elevation is the, you know, biggest factor, or you think it's the most important, then you would say, you know, as you increase in elevation, you're going to decrease in temperature. You're also probably going to decrease in the amount of precipitation that is involved. And so you, well, in extreme climates, you're going to, I mean, not here in California, because as you see here, it rains a lot more there than it does in the Central Valley. And that's because there's a set of mountains before you get to the Central Valley that the rain coming off the coast hits before it gets there. So it's kind of like this weird situation. But you could, you know, ideally you'll talk about a place that shows or demonstrates this particular thing you're talking about. So if you were going to, this isn't a good example. I mean, it's an okay example. So you'd say, you know, one example is, you know, the temperature at, you know, X place is this, and it's elevated, you know, it's at 3,000 feet. But if you go to 10,000 feet, then the temperature is this. And so that's going to impact, you know, the amount of vegetation and the types of soils, and you know, you could get into a lot of stuff, but ideally you'll come up with a specific example of where this phenomenon, whether it be latitude or ocean currents, and contrast it with a place that has a different one. So if you're going to say it's ocean currents, then you could talk about California versus Florida. So try and be specific, and get your post out there, and then get back in there and add to the conversation. I'm going to challenge you. I'm going to throw down the gauntlet. I need you to add to the conversation. So let's say, for example, they talk about Twin Lakes and Sacramento. And you're like, yeah, but you know, from my reading or my understanding, if it's higher in elevation, shouldn't it be receiving less precipitation? Maybe a better example would be to compare, you know, Sacramento to, you know, a different place that, you know, also has a similar situation going on, in the fact that it's in a rain shadow of another thing before it comes to the rain shadow of this thing, kind of thing. I don't know, just kind of add to the conversation. What I'm seeing is a lot of people, you know, congratulating each other and saying, hey, you did a great job, but not really adding, not really challenging, not really pushing the conversation and getting people to, you know, kind of think outside the box. And so I'm hoping this week we can start getting into, you know, kind of that poking people and getting them to think about what they're saying and challenging the idea based on other stuff that you've read. So, you know, so that's what I'm going to be looking for a little bit today. So, I mean, this week. So not a big, huge, you know, discussion post thing, but I'd like to see you engage in a discussion with your peers about these factors. And so maybe you look at this and you say, well, actually, you know, what's a bigger factor than the elevation thing that you mentioned is the relief. and the fact that Sacramento is in the rain shadow of a particular place and the Twin Lakes is on the windward side of the situation, being that it is a portion of the basin and range kind of thing. So yes, it requires you to do a little bit of thinking, but that's what I'm looking for. Just gonna say it. Okay, any questions? I have talked way too much. I can tell because my voice is starting to get dry. All right, so let me stop my sharing, get back to my estudiantes, see if there's anything in the chat. Nothing in the chat. Okay, so if you don't have any questions, it's been my pleasure. Top of the morning to y'all. Have a nice St. Patrick's Day. Don't drink too much green beer. Be safe, and I'll see you next week. If you have any questions, stick around or come to my office hours.